There's no federal mandate standardizing Master Electrician exams across all states. Each state's licensing board independently establishes its own requirements for the exam, covering both content and format. The National Electrical Code, or NEC, serves as the cornerstone for all electrician exams. However, state boards may incorporate additional regulations relevant to their specific jurisdiction. Therefore, it's crucial to verify the precise content of the Master Electrician's test with your state's licensing board. A single study guide cannot guarantee comprehensive coverage of all material featured in the Master Electrician's test. The scope and nature of study materials needed will depend on an individual's existing knowledge and experience. Some beneficial resources are official study guides issued by the State Licensing Board, NEC study materials, preparation course study guides from organizations, online forums, discussion groups, and sample exam questions. To effectively prepare, start studying well in advance of the exam date. Familiarize yourself with the test content and format. Employ a diverse range of study materials to address all necessary topics. Practice solving sample exam questions to pinpoint areas requiring further review. You may also want to think about taking a prep course or getting help from a tutor. State licensing boards frequently update electrician exams. Such modifications may involve updating content, modifying the layout, or altering the passing score. Consult your state's licensing board for the most current information available on the Master Electrician's test. When using the NEC to prepare for your Master Electrician's exam, understand that it is a comprehensive document. It includes the most widely adopted electrical installation code in the United States. It is revised and updated every 3 years. The NEC covers a wide range of topics related to electrical installations, from general requirements to specific rules for different types of occupancies and equipment. Some key areas covered in the NEC include wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and communications systems. Firstly, grounding and bonding are crucial for electrical safety, and Article 250 covers the requirements for grounding and bonding electrical systems to minimize the risk of electric shock and fire. Secondly, overcurrent protection is addressed in Article 240. It is essential for protecting electrical circuits and equipment from overloads and short circuits. Fuses and circuit breakers are common overcurrent protection devices. Thirdly, wiring methods and materials, covered in Chapter 3, deal with the acceptable wiring methods and materials for different applications, including cables, raceways, and conductors. Fourthly, equipment for general use, covered in Chapter 4, includes requirements for various types of electrical equipment, such as receptacles, switches, and lighting fixtures. Fifthly, special occupancies, such as hazardous locations, healthcare facilities, and places of assembly, have specific requirements outlined in Chapter 5 of the NEC. Sixthly, special equipment, like electric signs, swimming pools, and elevators, also have specific requirements in Chapter 6. Seventhly, communication systems, including telephone, data, and CAT-TV systems, are covered in Chapter 8 of the NEC. When studying the NEC, it is important to understand its structure and how to navigate it effectively. The NEC is divided into chapters, articles, and sections, each covering a specific topic. Use the index and table of contents to locate the information you need. The NEC contains many tables and examples to help you understand the requirements. Take the time to study these tables and examples carefully. Pay attention to definitions and terminology. The NEC uses specific terms with precise meanings. Make sure you understand these terms to avoid misinterpreting the requirements. Changes occur with each new edition of the NEC. Stay up to date with the latest changes to ensure that you are following the most current requirements. The NEC is a complex document, and it may be helpful to take a course or work with an experienced electrician to gain a better understanding of its requirements. State and local jurisdictions may have their own electrical codes that amend or supplement the NEC. Be sure to check with your local authorities to determine which codes are in effect in your area. When taking your Master Electrician exam, be prepared to answer questions about the NEC. The exam will likely cover a wide range of topics, so it is important to have a thorough understanding of the code. Here are some general strategies for preparing for an electrician exam. Firstly, review the NEC thoroughly, paying close attention to the key articles and sections. Secondly, practice solving sample exam questions to get a feel for the types of questions that will be asked in the exam. Thirdly, attend a prep course or study group to review the material and get help with any areas where you are struggling. Fourthly, familiarize yourself with the electrical codes and regulations in your state and local jurisdiction. Fifthly, get plenty of rest and eat a healthy meal before the exam. During the exam, read each question carefully and make sure you understand what is being asked. If you are unsure of the answer to a question, eliminate the obviously wrong answers and then choose the best answer from the remaining choices. Don't spend too much time on any one question. If you are stuck, move on to the next question and come back to the difficult questions later. Double-check your answers before submitting the exam. Remember to familiarize yourself with some key calculations often encountered in electrical work and on the Master Electrician exam. These calculations help ensure safety and compliance with electrical codes. Ohm's law is fundamental. It describes the relationship between voltage, current, and resistance in an electrical circuit. The formula is volts equals current times resistance, or volts equals amps x ohms. You can use this formula to calculate any of the three values if you know the other two. For example, if a circuit has a resistance of 10 ohms and a current of 2 amps, the voltage would be 2 amps x 10 ohms equals 20 volts. Power calculations are also key. Electrical power is the rate at which electrical energy is transferred in a circuit. It is measured in watts. The formula for power is power equals voltage times current, or watts equals volts x amps. You can also calculate power using resistance. Power equals current squared times resistance, or watts equals amps squared x ohms, or power equals voltage squared divided by resistance, or watts equals volts squared slash ohms. For example, if a circuit has a voltage of 120 volts and a current of 5 amps, the power would be 120 volts x 5 amps equals 600 watts. Voltage drop calculations are important. Voltage drop is a decrease in voltage along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction. The formula for voltage drop depends on whether the circuit is single-phase or three-phase. For a single-phase circuit, the voltage drop can be approximated by voltage drop equals 2x length x current x resistance per unit length slash 1000. For a three-phase circuit, the voltage drop can be approximated by voltage drop equals 1.732x length x current x resistance per unit length slash 1000. Where length is the length of the conductor in feet, current is the current flowing through the conductor in amps, and resistance per unit length is the resistance of the conductor per 1000 feet. Conductor sizing calculations determine the appropriate size of conductors needed for a specific application. The NEC provides tables and guidelines for conductor sizing based on the ampacity of the conductor and the ambient temperature. To determine the appropriate conductor size, you need to know the load current, the allowable voltage drop, and the ambient temperature. Conduit fill calculations determine the maximum number of conductors that can be installed in a conduit. The NEC specifies the maximum allowable fill percentage for different types of conduits. To calculate conduit fill, you need to know the size of the conduit and the size and number of conductors. Short circuit current calculations determine the amount of current that will flow in a circuit during a short circuit. This information is needed to select the appropriate overcurrent protection devices, such as fuses and circuit breakers. The method for calculating short circuit current depends on the complexity of the electrical system. Motor calculations involve determining the appropriate size of conductors, overcurrent protection devices, and motor starters for electric motors. The NEC provides specific requirements for motor circuits. To perform motor calculations, you need to know the motor's horsepower rating, voltage, and full load current. When preparing for your exam, make sure you are familiar with these basic electrical calculations. Practice solving problems using these formulas and refer to the NEC for specific requirements and guidelines. Being proficient in these calculations will help you to pass your exam and ensure that you are designing and installing electrical systems safely and in compliance with electrical codes. Also, remember that state and local codes may have additional requirements or modify the NEC standards, so always check with your local authorities for specific regulations in your area. Furthermore, familiarity with the NEC tables is paramount for anyone working with electrical systems. These tables provide essential information for determining safe and compliant installations. Some of the key NEC tables include Table 310.15b16, which is the ampacity table for conductors. This table lists the allowable ampacities of insulated conductors based on their size, insulation type, and temperature rating. It is used to determine the appropriate conductor size for a given load. Table 250.122 is the grounding conductor sizing table. This table provides the minimum size of equipment grounding conductors based on the rating of the overcurrent protection device in the circuit. Table 310.16 provides the allowable ampacities of conductors in raceway or cable. Table 430.250 lists the full load current for three-phase alternating current motors. Table 430.251 provides the full load current for single-phase alternating current motors. Table 430.52 shows the maximum rating or setting of motor branch circuit, short circuit, and ground fault protective devices. Table 220.12 is for general lighting loads by occupancy. Annex C provides conduit and tubing fill tables for conductors and fixture wires of the same size. Annex B provides examples, including ampacity calculation examples. When using these tables, it is important to understand the notes and conditions that apply to them. The NEC tables are based on specific assumptions and conditions, such as ambient temperature and the number of conductors in a raceway. You must take these factors into account when using the tables to ensure that your installation is safe and compliant. For example, when using Table 310.15b16, you need to consider the ambient temperature and apply correction factors if the temperature is higher than the table's reference temperature. You also need to apply adjustment factors if there are more than 3 current-carrying conductors in a raceway. Understanding these tables and how to use them correctly is essential for electrical safety and compliance. Familiarize yourself with these tables, practice using them in different scenarios, and always refer to the latest edition of the NEC for the most up-to-date information. Many jurisdictions adopt and amend the NEC, so it's vital to check your local electrical code requirements to ensure compliance in your area. Keep in mind that while prep courses and study guides can be valuable tools, they should supplement, not replace, a thorough understanding of the NEC and other relevant codes and standards. Experience in the field is also important. Hands-on experience can help you to understand the practical application of the code requirements. The more you work with electrical systems, the better you will understand how they work and how to apply the code. Continuous learning is crucial in the electrical field. The NEC is updated every 3 years, and there are always new technologies and techniques being developed. Make an effort to stay up to date on the latest changes and developments in the field. There are many ways to continue your education, such as attending seminars, taking online courses, and reading trade publications.